All right, guys. Good evening to you all. Can you guys hear me? Can you hear me? If you are here now, let me know. So just signify. All right, all right, all right. The class will commence in few minutes. Class will commence in few minutes. Just hold on. Just hold on. Class will commence in few minutes. All right. All right, guys. Can you guys hear me? Can you guys hear me? All right. Meanwhile, if you have friends who will be writing this forthcoming JAMB exam starting from tomorrow, do well to share the link of this live section with them so that they can be part as well. It's very, very important. All right, you guys will see me soon. I'm just at the back of my camera though. Okay, I'm just trying to set things up so that everything will be okay. So there won't be interruptions. Now let's start now. Let's start. All right. Can you all see me? Okay, so now let's say you come across this question in the JAMB exam. Here's the type of question you'll be asked on. For instance, question number 1, you will say calculate the oxidation number of sulfur in the following. I'm doing this so that irrespective of the way they ask it, you can actually solve. In the following: A, S8, B, SO2, C, SO3, D, SO4 2 minus, and E, lastly, H2SO4. Here is the question, class. Here is a practice question. So what do we do to solve this question? I believe everybody were in the same pace. Okay, so what do we do to solve this question? Now, listen everybody. Now, calculate the oxidation number of sulfur in the following. Okay, and everybody knows that sulfur is symbolized as S. Do you get? So what do we do? Now, this must be noted. This rule I'm about saying now must be noted. Now it says that the oxidation number, sorry, here is oxidation number, class. The oxidation number ON of a free element is 0. The oxidation number of a free element is 0. Now, what is a free element? Very easy. A free element is an element that is existing on its own without any attachment. Do you understand? So, for instance, we saw something like H2 in the JAMB exam. They say, what is the oxidation number of hydrogen in H2? Okay, hydrogen is just the element standing alone. So then, what becomes the oxidation number? Very easy. The oxidation number I said of a free element is 0. So the oxidation number of hydrogen rather here is going to be 0. Do you understand? It's actually very, very easy. Okay, it's actually very, very easy. I believe you all can see me, right? It's actually very, very easy. Okay, so I'm saying that the oxidation of a free element, that is a free element, is simply, because I'm explaining every single question here. So me explaining this, I'll be using it to solve this question A. So I just said that the oxidation of a free element, which is an uncombined element, is 0. So for instance, we are having something like, because I just use oxygen as a case, hydrogen rather as a case study. Okay, let's say we are having another element like N2, nitrogen 2, N2. You know, nitrogen is diatomic. Okay, contains 2 atoms. So what becomes the oxidation number of nitrogen here is going to be 0 as well. Because I said that the oxidation number of a free element should be what? 0. Okay, the oxidation number of a free element should be 0. Now, class, moving further, this must be noted. I believe we all are following. Okay, now option, look at this question, first question. Are you not seeing that S8? Now, no, don't be like, the number they'll be right here, you don't have to be like, the number can be anything. That's my point. The number can be anything. It can be 1 million, it can be anything. So the point here is what becomes the oxidation number of sulfur in S8? 0. So our answer will be 0 for A if we were to see this question in the JAMB exam. Are you following me? It's actually very, very easy. Okay, it's actually very, very easy. So let's get into the B part of this question. Okay, the B part of this question. And here is it. The question is SO2. What are they asking now? This is SO2 class. So they're asking us to get the oxidation number of sulfur. Very easy. Now this must be noted. Please note what I want to say now. It must be noted here that the oxidation number ON of oxygen in most states, the oxidation number of oxygen as an element in most states is -2. Do you understand? The oxidation number of oxygen in most states is -2. But the oxidation number of oxygen in peroxide have its own value. But the oxidation number of oxygen in most states is what? -2. So with this knowledge alone, we can actually solve this question. And if you observe, this is a compound. SO2 is a compound. So the first step, because that's various steps, but I'm going to solve them. And now if you observe, B is looking like C. So if you can actually solve B, then you'll be able to provide the answer for C for me, and you do it for me. So what becomes the oxidation number of sulfur here? What becomes the oxidation number of sulfur, class? Watch. What becomes the oxidation number of sulfur? Very easy. Watch. Now, it's determined by some set of arbitrary rules. Now, the one I'm looking for, I'll make it X. I'm looking for sulfur, then I'll make it X. Do you understand? But before I do that, I will have to equate everything to 0. That will be the first step. Equate to 0. It is quite different from this A part. Please watch out carefully. First, I will equate everything to 0, which I've done now. And then, I will now then make what I'm looking for X. Do you understand? I'm looking for the oxidation number of sulfur. It's going to be X plus Now, what did I just say is the oxidation number of oxygen in most states? It is -2. Then, because I saw oxygen, I'll then write here as -2. But how many atoms of oxygen am I having? How many atoms of oxygen am I having here? 2 atoms. 2 atoms. So then, you will times. So what times? So it's going to be times 2 is equal to 0. If there was 3, I'll times by 3. So next will be x plus, now -2 times 2, that is -4 is equal to 0. So next, plus minus, that means in mathematics, plus times minus is what? Minus. Do you understand? Minus is superior, so it will affect plus and plus will vanish, remaining just minus. So it's going to be x minus 4 is going to be 0. So what become x? What become x? We then, this guy crosses over and become positive. Do you understand? So x is going to be 0 plus 4. So what will be x? 4. Do you understand? That is why this compound SO2 is regarded to be called sulfur. Listen, sulfur. How many oxide? Sulfur 4. Okay, oxide. That is why SO2 is called what? Sulfur 4 oxide. I believe this is clear. It's actually very easy. Okay, it's actually very easy. So with all of this said, I'm going to give you one practice question. So it's solve for C for me. Look for the part of C. Follow the same step. You'll be able to get into without stress. Do you get? So do that carefully for me and provide the answer. What becomes the oxidation number of sulfur in SO3? So do that for me. Do that for me. Very good. You guys are getting it. +6 is the answer. Do well to share these live videos to your friends. It's going to help them. Okay? It's going to help you all. Do well to share these live videos to your friends. Okay? So that's for that. +6. I believe you know why the answer is +6, right? You guys are getting it, of course. So you actually know why it's like that. So it's very, very important. It's very, very important. Okay? So that's for that class. So let's progress. Now I want to wipe. I want to wipe. Can I wipe? Can I wipe? Let me know. Can I wipe? Can I wipe? Can I wipe the board? Alright. Alright. Let's go. So class, we have successfully solved this part A. We've successfully solved B. Now you all solved for C. So let's solve for D. Now if you observe D, now D is a radical. D is what? A radical. Here is it. SO4 2-. Please note, whenever we are to solve the oxidation number of a particular element for a radical, you are to equate it. You are to equate that radical or that substance with the charge given. Do you understand? With the charge given. If you observe, the charge is -2, so then normally I say equate to 0, then I will equate to -2 in this context. It's going to be S. What we are now, remember we said that, listen, what we are looking for, make it X plus, no, it's plus, it is plus right next, okay? It is plus right next. And oxygen oxidation state was it? -2. You can see, this I just said is going to help us solve this question. It's very easy. -2. And how many oxygen do we have? 4. So it's -2 times 4. I'll put it in the bracket so I don't have any stress. So then I will equate everything to the charge. And the charge is -2. I believe you understand. I believe you understand what I just explained. Because if there was -1 million, I put it there as well. So then it will become X. Now what are we having next? Plus -2 times 4, that's -8, equal to -2. What become X? Minus times, plus times minus, what are we having at the end? -8 is equal to -2. So then we guys goes, so it's going to be what now? +8, right? That was minus before. So when you cross, it becomes +8. So then X now equal to that 8 plus 8 equal to -2. Do you understand? So 8x now equal to what now? 8 minus 2, that is what now? Sorry. Yes, now that's it. 8 minus 2, that's +6. Yeah, that's +6. That's +6. So the charge, sorry, so the oxidation state of sulfur here is what are +6. Class, is it clear? What I just said, is it clear? Is it clear? Let me know. Is it clear? Do you understand what I just said? Yes, sure, it's going to be available. It will be saved. It's going to be saved. The video will be saved. Okay, just keep on watching. If you have data or maybe your phone is low, you can just maybe tomorrow morning or when you charge your phone, the video will be available. Is it clear? All right. It's not clear. What exactly is the problem? You guys said that here is SO42 minus. When you see questions on that aspect, you equate it to the charge. Do you understand? Equate to the charge which we did. So then S. No, some people are just joining. That's why you're not getting it clearer. Do you understand? But it's actually easy. Do you understand? It's actually very easy. It's actually easy. You can do it. Maybe after as we progress and progress, get to master it well. Because I'm going to solve different type of question in chemistry tonight. Do you understand? Get ready, get ready, get ready. So that's for that. So let me give you guys a likely question on these. I just solve. Not like we give guys. We have here as NO3 minus 1. Okay, so everybody solve for this for me. Solve for nitrogen. Remember, follow the step. Oxygen, the solve, and what become the oxidation state of nitrogen? It's simple. That's why this guy just call it nitrate 5, nitrate 5, nitrate 5. So tell me, solve it if you actually get that 5. Do it for us. Do it for us. Let's see if we get the answer. Okay? Do it for us. Do it for us so we know you get the answer. It's actually clear. If it's not clear, it's your network. Not that you are, not because I'm saying 5. I'm saying that the answer is 5 and you are writing 5. I hope you solve that it's actually 5. Because I'm going to solve it too. Now, let's solve together. Nitrogen will make it X. Now, what's the next sign I said? Plus oxygen. Oxygen. Oxygen is what? What's the oxidation state? Minus 2. But since we're having 3 atoms, it's going to be times 3 is equal to the charge, which is minus 1. So X, what are we having here? What are we having here? Plus minus 6 is going to be now. It's easy. It's easy because minus 2 times 3 is minus 6. Yeah, that's it. Yeah, so we're having X, then minus will colonize plus. Minus is very, very negative. So it will just attack plus and defeat plus. So then it's going to be minus is equal to minus 1. So X will now be equal to this guy coming here is going to be plus 6. So then we're having plus 6 minus 1, and X is going to be what? 5. But to be specific, plus 5. Because in the option, they may actually put minus 5 there, plus 5 there, so we know what to do. I'm going to solve a question JAMB asked. Meanwhile, if you are here presently and you haven't watched my videos on those 40 chemistry questions I to solve here on my channel, make sure after this live section, make sure you go watch those lessons. It will help you improve greatly, okay? They're very, very important. I did so many things there. Alright, so that's for that. I believe you guys got it clearly. Okay. Alright. Alright, so let's progress, everyone. Let's get back to the question I gave, which is E. Here is H2SO4. Please watch you. H2SO4 down. We now need to know something. What are we looking for? Oxidation state of sulfur. Now, if you observe, what are the 2 elements here? Hydrogen. So then, we need to understand the concept of the oxidation state of hydrogen. Okay? Now, hydrogen in most compounds, the oxidation number of hydrogen in most compounds is +1. Do you get? Hydrogen oxidation state in most compounds is what? +1. But in hydrides, it is -1. Don't worry, we're going to talk about those guys. So then, and this does not have a charge. So we'll not equate it to any charge. We equate it to 0. Do you understand? We'll equate it to what? 0. Then, what is the oxidation state of hydrogen? +1. And how many hydrogen we have in here? 2. So it's going to be times 2 plus sulfur, what we are looking for, X. Do you get? Plus oxygen. What's the oxidation state I said oxygen is? -2. So it's going to be -2. Put it in the bracket. Okay. And how many oxygen do we have? 4. So -2 times 4, close bracket is equal to 0. So then we're having +2, right? Plus X. Hope you are following. It's simple. Plus into -8. Do you get? Okay. -8 equals to 0. So plus x minus 8 is equal to 0. Hope you understand how this minus plus vanished. But minus times plus times minus of the same, or any of them, so I'm still going to give a minus. So then what are we having? X now equal to, let's move, this guy goes here, and also this guy moves as well. So it's going to be 0. Here was minus 8. When you cross, it's going to be plus 8. When plus 2 cross, it's going to be minus 2. So x now equal to 0 is out already. So we're having plus 8 minus 2. X now equal to what now? Plus 6. Do you understand? That is why this compound is pronounced as hydrogen. How many oxygen here? 4. Tetra. Anytime we talk about oxygen, we talk about oxide or oxo rather. So hydrogen tetraoxosulfate 6. Hydrogen tetraoxosulfate 6. Is it clear? It's actually very, very easy. It's actually very, very easy. Okay? It's actually very easy. Meanwhile, if you are here and you haven't yet subscribed to my channel, make sure you do well to hit on the subscribe button. Share this, let all your group chat you are in, share the lesson to them. Okay, we are just 329, which is not much. Tell others to join. Do well to share to them so that they can click on it, and then the class will be saved. Okay, for those who basically are not, maybe your phone is down, the class is being saved. Share the live class to so many people. Okay, so do you want the class to end? Somebody's asking when will the class end. All right, so let's end it all. Can we end it now? Somebody just said wish. All right, let's progress. So that's for that. So let's wipe. So I believe now. Let me bring the question JAMB asked. Let me bring out the question JAMB asked to everyone here. Here's the question. The question is: calculate the oxidation state of chlorine in HClO4. It's simple. Everybody solve for me. Solve it and get the answer. Okay, I'll be uploading a video soon on my channel. This night it will be out. Okay, from now you're watching, it's going to be out. And I actually solved this particular question there. So solve it before you even watch it. HClO4, what's the oxidation of chlorine? Hydrogen oxidation is plus 1. Here is minus 2. So do it for me. Do it for me, everybody. Okay, solve it for me, everybody. Solve it for me. Yeah, minus 2 plus 1. So what is the oxidation state? Very good. People are getting 7 already. Very good. Okay, very good. Shows that you all are actually very active. Okay, the misery gamer. Okay, exciting all right. So let's progress. Make sure. Yeah, definitely. I'll pray for you guys. Okay, at the end of the class. My own is just follow, be active. Just believe you can do all of these things. You can do it. The JAMB exam is not an exam that cannot be broken. You can actually break it. Do you understand? People have written and have done so well. You can actually do it as well. All right. So very good. Okay, I should solve. Some people are saying simple. What did I say? Since it does not have a charge, we equate it to 0. And hydrogen oxidation state is plus 1, which we've said already, plus x, which we are looking for chlorine, plus oxygen, which is minus 2 times 4, is equal to 0. Is it clear? Yes, it is. So what happens next? Plus 1 plus x plus 1 minus 2, that's minus 8, is equal to 0. I believe you are following now. Minus 2 times 4 is minus 8. So plus 1 plus x minus 8 is equal to 0, because this plus will vanish. Because plus times minus is minus. So x will now be equal to 8 comes here, and plus 1 comes here as well. So then it's going to be 0 plus 8 minus 1. Okay, 0 is out. X will be equal to plus 8 minus 1. And what's the answer? Plus 7. Do you get everyone? It's actually easy. Okay, it's actually very easy. It's actually very easy. No, I'm not ending it. So class, before I leave this particular aspect, is it clear to you all? So we'll go to another topic. I might treat organics, I might treat anything. Let's just be doing the one. Let's just be solving. Get ready, everybody. Class, let's progress, right? Is this clear to everyone? Don't worry, watch the video again after the live class. Just get ready, everyone. Okay. So class, let's leave this topic right and go to, okay, let's progress. I'm done with this guy and let's go to something else. Now let me quickly work on organics. Everyone, here is the question. The question says, the reaction, listen everybody, the reaction between an alkanol and an alkanoic acid will produce dash. But though they had options like option A, alkanals, it's out. This can never be the answer. Alkanones, out as well. Option C, alkanoate. And option D, none of the above. Simple. Here is an organic chemistry question. Very good. Now, listen everybody. Alkanals reacting with alkanoic acid. What do you think we are to get? We'll simply get a group of organic compounds regarded to be called esters. And esters are also regarded to be called alkanoids plus water. Do you understand? We'll get water at the end. Do you understand? But when we reverse this reaction, it is called hydrolysis. Do you get? But I'm not talking about that. I'm discussing about esters. Now, esters also got alkanoids. So what becomes the answer to this question? Option C. Do you get? So this reaction is regarded to be called not alkanals, not alkanals. Now let me show you guys why. Everybody listen. Let me actually show you guys how we got this. It's not just saying it. Let's show you guys. Alkanals, what is their general formula, class? Sorry, not alkanals. Alkanols, rather. Alkanols, not alkanals. Alkanols. So what is the general formula for alkanols? Simple. Alkanols general formula is RO bond OH. I believe you are following. So if I don't write alkanols like this is the general form for alkanols. They have their formula. RO bond OH. Remember this group, an alkyl group. Do you understand? An alkyl group is a derivative of alkane that loses one hydrogen, and it is actually this CnH2n plus 1. Though there are some things you must note here. Wherever for alkanoic acid, here is the general formula. It is alkanoic acid, remember it's ROCOH, right? But look at something. Let me write it in structural form. RO bond C, RO bond C, OO, right? So carbon is bonding to one of the oxygen with a double bond. That's how it works. Carbon bond with this oxygen with a double bond, and then remaining OH. So here is the OH. So what do we get as our product? Very easy. This reaction works in the presence of H2SO4 as the catalyst. Do you understand? It works in an acidic medium. It works in an acidic medium. Are you guys following me? It works in what? An acidic medium. It works in an acidic medium. So what do we get? Simple. Watch. I want to remove water. Because at the end we got water. So look, I want to remove water. This is how I remove the water. I've removed water. So if you observe, what did we get here? We had H bond OH. Do you understand? And this is regarded to be H2O. H2O. Do you understand? H2O. Do you get? So that's for that. So when I've gotten that, so water will come here as written initially, and then what becomes our final product? Let me take this part first. So we are having RO bond C, double bond O. Nothing here, so then we need, we need something for here, so which is this remaining to O arrow. Because I can't write RO, I can't say bond RO, no, because it is carbon that is bonding with oxygen, not arrow, so it's bond O arrow. Are you following? And this, when I condense it, we have ROCOO arrow, and what is the general formula for this? Alkanoids, also regarded to be called esters. Do you understand? It's actually very, very easy. Okay, so that's for that, class. Let us progress. Stoichiometry, no problem. I'm going to work on all of this. Don't worry, just take it small. It's simple. Okay, please, it's actually very easy. My own is just note what we just said. Just note it. It's very, very important. Let's progress, class. Let's progress. I'm about wiping the board. Can I wipe the board? Can I wipe the board? Let me know. Can I wipe the board? Can I wipe the board? Let me know. I'm backing my camera now. Don't worry. The topics are you guys are. Don't worry. We'll talk on them. We can't just work on them right now. Let's wipe. I want to wipe. I want to wipe. Now, let me draw something for us. Here is a question you must note. Okay, here is something you must note. Okay, let me draw this cell. Let me see if you guys will get the type of cell that this I'm drawing this. Okay, let's say we are having something like this. We are having something like this as well. We are having something like this. There is a container holding them. There is a container holding them like this. Okay, now class, there is a direction like this. This is one type of okay, let me not say much. This topic is on electrolysis, okay? Electrolysis. This is a cell. To be specific, it's called an electrolytic cell. Do you understand? We have different types of cell. We have electrolytic cell, we have electrochemical cell. Electrolytic cell, this is where electrolysis occurs as a process. Electrolysis occurs inside the electrolytic cell. This thing you are seeing is the direct current source. And this arrow you are seeing coming towards direction shows that the way the current flows is in one direction. It flows opposite the current. It flows opposite the current. Do you understand? And then goes to these two stuffs that look like stick. They are called electrodes. What are they called? Electrodes. They are called electrodes. Now, this is what I want to make you guys to watch out for. Electrodes are of two types. We have anode and what? Cathode. Now, it must be noted here that the anode for an electrolytic cell is positive. The cathode is negative. Note this. The anode for an electrolytic cell is positive, while the cathode is negative. Do you understand? Please note it or note this. Note the I just said. Now, all these things you are looking at, they are called electrolytes. All these things that inside where these electrodes are embedded, they are called electrolytes. And electrolytes, basically, they are always compounds. They are not elements. Electrolytes are compounds, they are not elements. You understand? They are compounds, they are not elements. If I was to be teaching physics here, then I will be talking about something that, now, electrolytes are compounds that conduct electricity in liquid form. So it means that the only way electrolytes can conduct electricity is when they are in liquid form, when they are the only state of matter which is liquid. We have three major states of matter: solid, liquid, and gas. But for them to conduct electricity, they must conduct electricity when they are in liquid form, and they are also compounds. But if I was to be teaching physics, I would say that something that conducts electricity in the three states of matter is actually conductors. And conductors are elements. Do you understand? So the difference between electrolytes and conductors is that conductors are elements, electrolytes are compounds. Do you understand? And there is decomposition occurring here, decomposition of this electron. While for conductors, no decomposition occurs. Do you understand? There are so many differences here. But just note what I just said. Now for this electrolyte, there are two groups. You have weak and strong. It's like our strong acid and also strong or weak acid. You know, strong acid, they ionize completely in solution. Same applies to strong electrolyte. They ionize completely in solution as well. Are you following me? Simple, okay? They are all easy. I'm just trying to take this more so that you guys can just learn. Okay? You learn. Be calm, don't worry. Alright. I believe I'm following you. So that's for that. The other thing is about the electrolytic cell. Okay. Now, before we progress, let me quickly say something. I believe I can wipe now. I just explained the concept about electrolytic cell, and this is where electrolysis occurs. And there's something you have to note on electrolytic cell as well. It converts electrical energy to chemical energy. Electrolytic cell converts electrical energy to chemical energy. Electrical to chemical energy. Now, this I want to say now must be noted, everybody. I saw some people right here to teach on redox, something like that. So please note this. Note this, everybody. Note this acronym. It's called cryo. Okay? Cryo. This C means cathode, whereby arrow means reduction. Are you getting now? This A means anode. and then O means oxidation. Are you following me? Simple. Now, it means that both of them goes together. If they ask you what type of reaction, because in electrolysis you have two major reactions here, which are reduction and oxidation. So what type of reaction occurs in the cathode? In the cathodic half of a reaction, what type of reaction occurs? Reduction. But in the anode, what type of reaction occurs? Oxidation. Are you following me? It's simple. Now, we then need to define what reduction and oxidation is based on something, based on electron. And I will call it oil rig. Oil rig. That's my own acronym. Oil rig. Okay? What is oil rig? Oil means oil is oxidation and is loss. It is loss of electron. Do you understand? It is loss of electron, whereby this is gain of electron. I believe you are following. Loss of electron, the other one is gain of electron. The loss of electron, while the other one is gain of electron. Loss of electron, while the other one is gain of electron. Are you following me? I believe you are following now. So now, before I even progress, let me quickly say something. Here is for an electrolytic cell. Electrolytic cell, we all have agreed that in the anode should be positive. Cathode should be what? Negative. But for an electrochemical cell, for an electrochemical cell, it is the opposite. Class, tell me the opposite. It is the opposite for an electrochemical cell. It is the opposite for an electrochemical cell. It is the opposite for an electrochemical cell. Okay, it is the opposite for an electrochemical cell. If you are here watching me now and you haven't yet subscribed to the channel, or you haven't yet shared the link to your friends, do well. Make sure you share the link to your friends, alright? So that they can watch. We have so much to do. We learn so much today, by God's grace. So tell me the opposite of it. And very good, very good. You guys are very smart. For that person who asks on chemical equilibrium, I already have it on my channel. Go watch it there. Go watch it there on my channel. Yeah, very good. So class, on metals, non-metals, I will throw some lights on them. They are all easy. Now, please just understand what I just said. They are important. Though it's important for us to understand deeply into every single concept. But right now, there is no time, so we have to just do what we can for the sake of the exam. So on to why I believe you've written these I've said. Screenshot will be very, very fast. Screenshot. And another thing about electrochemical cell is that for an electrochemical cell, this is an electrochemical cell. There is volts here. Then we have something like this. The other one we have something like this just now. Yes, yeah. Okay. Now I'm just doing fast drawing the diagram. Alright. So there is something that holds these electrodes together. It's called the salt bridge. It's a salt bridge. The salt bridge basically helps for the transfer of ions from the electrodes. Okay, from the electrodes. Another thing about electrochemical cells is that it occurs in two different compartments. These are the compartments. Remember, if this one is negative, this one is positive now. Yeah, this one is anode, this one is cathode. We all have agreed. Okay, here is the electrolyte, here is the volts. Okay, so that's for that. Are you following me? Alright, so let's progress, class. Meanwhile, you are here, you haven't yet subscribed. Make sure you click on the subscribe button. Share this link to your friends. Okay? Share this link. You don't have to give up. Even if you are here now, you've not really studied much. By God's grace, at the end of this class, I believe you'll learn much. Do you understand? You learn. Don't be scared. It's easy. So can I wipe? Yes, I can. I said do more screenshots. Screenshot them. The function of that salt bridge is to complete what we call electric circuitry. Electric circuitry. Now let's walk towards this concept. Here is X, here is A, here is Z, here is X, here is A, here is Z. Here has plus or minus, here is nothing. Both of them are atoms, I know. But one is not just a normal atom, one is a charged atom. whereby the other is a neutral atom. Why did I call this one a neutral atom? It is called a neutral atom because it has no charge. While this one is called a charged atom because it has charge. The charge can be either positive or negative. If it's positive, it should be called a cation. If it's negative, it should be called an anion. An anion. Do you understand? So here is the B and Z. A up here has a name. You can call it atomic mass. Atomic mass, you can simply call it mass number. Do you get atomic mass or mass number? Then whereby this can also be called atomic number or proton number. So I want to tell you guys something because they ask you in your exam. They will ask you surely in your exam. They will ask you, calculate the proton, electron, and neutron for this atom. How will you do it? Simple. Proton, electron, and neutron. Proton is always this value that is down. Proton is always Z. And for a neutral atom, proton equals electron number. Are you following? For a neutral atom, proton number equals electron number. Proton number equals electron number. Okay, so then since electron number is here, so what becomes my electron number? Proton number, which is same as Z initially. And how do we get our neutron? Neutron is solved by saying A minus Z. Do you understand? It is solved by saying A minus Z. What is up minus what is down. This is for the pattern for a neutral atom. So then we work towards charged atom. We are still asked to get proton, electron, and neutron. Remember, proton, electron, and neutron, these are the particles found in an atom. Generally, protons are positively charged, electrons are negatively charged, neutrons are neutral. So how do we get the proton, electron, and neutron for a charged atom? Simple. Proton number does not change, and A and Z, for A and Z here still remains the same. Are you following? Hope I'm not too fast though. Let me reduce my pace a little. It's actually easy. Hope I'm not too fast. Let me know. Hope I'm not too fast, class. Hope I'm not too fast. So that react so I will know if you are following. Can you guys hear me? Let me know. Alright, I'm going to take it down. I'm going to reduce the pace. Just be calm. Proton, electron, neutron. So what's the proton number? It does not change. Z. Do you understand? Now what's the electron number? Now I'm going to work on that. But neutron number does not change. It is A minus Z as well. So the only thing that will change is getting the electron number for a charged atom, and it's done by a formula which is electron number is equal to proton number minus charge. What did I say? Proton number minus what? Charge. Proton number minus charge. Here is it. I'm going to use the paste. Don't worry. Proton number minus charge. Do you understand? So with all of this said, let's solve practice question. Together. I want to solve it on this box. Here is sodium Na, and here is 23, here is 11. Now class, first of all, looking at this sodium, and they asked us to get a PEN. I don't want to wipe the board first. They asked us to get PN. Class, looking at this sodium 2311, is it neutral or charged? Let me know. Is it neutral or charged? Let me go to my phone there and see your answers. Is it neutral or charged? That's sodium I'm looking at the board now. Is it neutral or charged? Answer now. Alright, and Yola. Very good. So then, which pattern are we to use? Is it this or this? We have to use this pattern to solve the question. So what did I tell you guys proton number is? Proton number is always Z, so proton number is 11. What becomes electron number? It is same as a proton number for a neutral atom. But please note this, our proton number and electron number, they are not equal for a charged atom. They are not the same. That's why it has its own formula. So then, how do we get a neutron number? It's not by saying A minus Z. What is up minus what is down? What is up, class? It is 23. What is down? 11. What's that? 12. Is it clear? Yeah, it is. It's simple. It's actually very easy. Let's work towards this, which is Na 23, 11, and here is plus 1. This is still sodium, but this sodium this time around is charged. Sorry, I'm trying to just use the board everywhere the board around to right now. Okay, here is P, here is E, and here is N. So then, what is my proton? How do we get a proton for a charged atom? Proton number does not change. It's the same as what is down, which is Z. And what is down? 11. Now leave electron alone. Let's go for our neutron. Come to electron last. Neutron basically is still same as what is 23 minus 11, which is what is up and what is down, which is 12. For electron, is proton number minus charge. Okay, what's the proton number? Proton number is 11 minus our charge. Charge is plus 1. Do you understand? 11 minus plus 1. So then 11 because minus times plus. You said that already, that's minus. So 11 minus 1, that's 10. So electron number becomes 10 here. Do you understand, class? Hope you understand what I'm saying now. They are all easy. I'm going to give you one practice question to solve. Let me leave it on the board first before I give you yours. It's very easy, class. It's actually very easy. It's basically your network if you haven't seen the board. Okay. All right. That's why you have. I don't know how to do that though. Let me wipe. So you solve your class. Let me wipe this part on board. You can actually do it. It's simple. Solve for aluminum for me, everybody. Okay. Charge aluminum and neutral. This neutral first. 27, 13, PEN, and then you solve for another, which is AL 27, 13, and there is plus 3 PEN as well. So solve for me, class. What becomes our proton, electron, neutron? You know all of these things are easy. They're very easy. Okay, they're very easy. Do it for us. Let us know some radioactivity. I already have it on my channel. So if you just list them, I already have them on my channel. So do well to watch those lessons. All right. I think someone have gotten the answer for. All right. You guys are doing well. You guys are doing well. So just keep on doing well. Keep on doing well. All right. So that's for that. I believe you guys have solved it now. It's very easy. Proton number should be what is there. So proton is 13. Electron number and proton number for the neutral atom are the same. Here should be 13 as well. Going by 27 minus 13, what should be that? 27 minus 13. That's 14, right? So here should be 14 as well, which is 27 up minus down. 27 minus 13. That's neutral one because we can have 14. But here is 13, yes. But here should there be 13 as well? No. Therefore this one, both of them are not the same to get here. So then here we solve this for little first. This one is still 27 minus 13, and that's 14. And here is P minus charge, right? Proton number minus charge, which we said. P now there was a proton number 13 minus plus 3. So P will be equal to 13 minus 3, which is equal to 10, right? Yes, it is. It is. Do you get what I just said? It is. It is very easy. It's very easy. Look at it very well. You get it very well. It's simple, class. It is simple. So let's progress. Very easy. Let's progress, class, for another concept. I want to teach you guys something else. Okay? My mind just has to say something, and I want to say it now. Alright, so let's progress. I believe I can move. Half-life radioactivity, I have it on my channel. So don't stress yourself. Go find it on my channel and watch it. Go find it on my channel and watch it. Now, everybody take note of these things. Now, we have some compounds that are used as drying agents. Do you understand? We have some compounds used as drying agents. You hear about drying agents now? They dry gases. Okay, this one, they call it H2SO4. H2SO4 is a compound that dries all gases except they've asked it to JAMB before, except ammonia, NH3, and then H2S. You understand? Now we have one guy like that dries all gases. It dries all gases. We call it silica gel. It dries all gases. It dries all gases. Note this. Okay, we have another one like that. They call it fused calcium chloride. Fused calcium chloride dries all gases except ammonia. except ammonia, NH3 as well. Whereby we have another which is a P2O5, phosphorus oxide, phosphorus 5 oxide. This one dries the same thing, few scatter as does. And lastly, we have this guy called CaO, it dries ammonia in particular. It dries ammonia in particular. NH3 in particular. Note these, so they are very important. They help you across grades tomorrow for exams. Okay, so that is for that class. That is for that. It's simple. They're easy. I believe you are following. I believe you guys are following. I believe you are following now, right? Everyone, I believe you guys are following. Let me know. Alright, thank you very much for that. So we are progressing. At least we are doing things, we are working. Alright, so can I wipe this? Do more screenshot it so it's very fast. Screenshot it. Alright, so let us progress. On to wipe. Now there is something they call it, the one element is carbon. Carbon exists in different allotropic form. We have two major allotropes of carbon, which are the crystalline allotropes, and then we have the amorphous allotrope. On the crystalline allotropes of carbon. Now, let me quickly say something. I might not be able to do everything right now, but God will help us to touch. Now, it's about teaching or touching what you will see in the exam. That's the most important thing right now. Another thing is this. I can see some person saying you don't understand electrolysis, you don't understand radioactivity, this, that, stoichiometry. I don't think you should be asking me I should teach stoichiometry right now. I already have it on my channel for months, almost a year now. So make sure after this class, make sure you go there to my channel, go and watch on. I have them. All calculation topics have been treated on my channel based on different topics: electrolysis, solubility, radioactivity. Think about it. Chemical equilibrium, I've made justice to those guys. So make sure you go watch it. Now, here are some theoretical things you must know. For the crystalline allotropes, we have diamond, we have graphite. We also have something called graphene. We have graphene, we have Buckminster, fullerenes, there are many. Do you understand? Nanotube, nanoforms, all of these are crystalline allotropes carbon, but majorly these are the two you must know for the sake of your JAMB exam. And then amorphous allotrope include coal, include soot, include lamp black. Do you understand? Include charcoal. There's something called charcoal. Charcoal can be of three. We have wood charcoal, we have animal charcoal, and then we have the sugar charcoal. Now, among the purest, if they ask you which is the purest form of amorphous carbon, you will simply say it's what? Sugar charcoal. Sugar charcoal. Coal can be of different kinds. We have peat, we have lignite, okay, we have bitumen, we have anthracite. All of these are examples of coals. Do you understand? Now, lignite is also called brown coal, and it is mainly found in Nigeria. Do you understand? Lignite is also called brown coal, and it's mainly found in what? Nigeria. Lignite is also called brown coal, and it's mainly found in what? Nigeria. Alright, so when you burn coal in the absence of air, it's called destructive distillation of coal. When you burn coal, you take coal and burn it in the absence of air. Absence of air means the absence of oxygen, because oxygen as an element supports burning, supports combustion. You think about that. Okay, so then it's basically regarded to called destructive distillation of coal. Do you get destructive distillation of coal? There's so much to learn. And it's important as you are here, make sure you know how to name organic compound perfectly. I already have it on my channel. Go watch it to help yourself. Go watch all of those lessons. Okay, I'm just telling you things, theoretical things to watch out for your exam. Alright, now we have a test for some metals. Let's go towards test for some metals. Hey, I hope I've not cleaned the board. Okay, let me wipe you. I'm supposed to write this thing very fast. test for some metals, we have different metals like likes of sodium. What is the test of this metal called sodium? Sodium. The test basically, the flame test like that is going to give a golden yellow flame. Golden yellow flame. And it appears invisible when viewed with a blue glass. It appears invisible when viewed with a blue glass. It appears invisible when viewed with what blue glass. We have another K, potassium. This one lilac, lilac flame. Right. Yes, lilac flame. We have which metal should we talk about? Copper, bluish green, lead, liquid blue, calcium, brick red. Okay, brick red. Note this guy very well. It's very important. Brick red. That's for calcium. That's the flame test. Brick red flame. Brick red flame. Brick red red flame. Okay, brick red flame. Yeah. These are some metals. I said this one. One of them is vivid blue, bluish green. Okay, bluish green. Okay, these are some popular elements, metals that you may likely watch out for, okay, in the exam. Okay, so these must be noted. All right, this must be noted, everyone. And I believe eyes of gas laws, like everyone, hope you can solve questions perfectly on gas laws. That part is simple as well. I have to my channel, okay, Boy's law, Charles law, ILD gas law. They're all easy just for you. So calculations in chemistry are very easy. It's actually one of the simplest areas of chemistry. Okay, so it's important for you to basically understand it well. Okay, it's actually very easy. All right, there's something I think I have to say in organics. Yeah. Now, class, everybody watch out for this. Let's say, we have compounds that are single bonded, compounds that are double, and compounds that are triple. Single bonded compounds are divided to called alkanes, and alkanes are also called paraffins. Do you understand? Whereby this is alkene, double bonded, and they're also called olefins. Whereby this is alkynes, while they're also called acetylene. Alright, so alkanes, hybridization sp3, sp2, and sp. Please note this, so sp3, sp2, and sp. Do you understand? I have no time for that, okay? Alright, now here is a question you must watch out for in your exam. Type of question that will likely come outside in your exam. Don't just give you a compound. They will say the above compound has what hybridization. Then I say option A, sp2 only. Option B, sp and sp3. Okay. Option C, when I just say sp3 only. Option D, none. It's very easy. What did I say? Compounds with single bond, they have sp3 hybridization, double bond sp2 and triple bond sp. Now, if you observe, what are the two types of bonds you can see here? Don't be scared about how the compound was written. Just look at your bonds. So I can see single bond around, and then I can see triple bond. So we have two types of bonds here: single bond and triple bond, single bond and triple bond, sp3 and sp. What becomes the answer? sp and sp3. Option B. Class, is it clear? What I just explained, is it clear? Do you understand what I just explained? It's simple. Very easy. It's very easy. Let me know if you understand what I just said. Let me know if you understand what I just said. Comment down. Let me know if you understand what I just said. Let me know if you... Now, if you are here, you haven't yet subscribed, do well. Make sure you subscribe. Make sure you subscribe to the channel so you don't miss out. Okay, I said that compounds with single bond, that sp3 hybridization, compounds with double bond, sp2, triple bond, sp. So this compound, I'm looking at it, that's single bonds around and also a triple bond. So what type of hybridization will they have for the carbon? So what type of hybridization will they have? SP and sp3 hybridization. Do you understand? It's simple. It's simple. It's simple. It's simple. It's simple. It's simple. So let me know if you understand what I just said. Whoa. All right. OB of chemistry. Yes, I am. I am the OB of chemistry. All right. So make sure you share these lessons with your friends. Okay. And all right. Now, there are some things you must know, but not like there are some key things you should watch out for. There are some key things. Let me quickly say one again. Let me wipe. Yes, I can't wipe. Now, I think on chemical equilibrium, there's something called equilibrium constant expression. There's something called equilibrium constant expression. Let's say we have a reaction like NO2. This is a JAMB question. So give me N2O4. Is this reaction balanced? No. If I put 2 here, will it be balanced? Yes. So they will now ask you, what is the KQ for this reaction? Write out the equilibrium constant expression for this reaction. Simple. It is simply done by saying product divided by reactant. Do you understand? Here is my product. Right hand side is your product. When you stand like this is your product, this is your reactant. But if we're talking about biology, you stand anatomically. Do you understand? Science, this is my right, this is my left, this is my product, this is my reactant. But biology, anatomically is like this to stand. Do you understand? This is my right, this is my left. Do you understand? So, but do you in science now, like normal physical science, physics, chemistry stuff. So this is my right, this is my left. Okay? So then, what is my right? It's not N2O4. I'm about writing the equilibrium constant expression. Simple. It is not my same product over reactant. So what is my product? I'm having just N2O4. Okay? And you put it in a bracket. And raise it to the power. And what's the power? Though I'm not seeing anything. I'm not seeing anything, but there's an invisible one there. Do you understand? Whenever you're not seeing anything standing in front of a compound or an element, there is an invisible one. I'll raise it to that. Please watch, it is easy. I will now then divide by reactant. My reactant, I'll pick it without what is standing in front of it. I'll pick it, write it in a bracket, which is NO2. Do you understand? And raise it to the power of my coefficient, which is 2. It's simple, class. Look at it, you will get it. This is how you write the equilibrium constant expression for a reaction. Okay? This is how you do it. This is how you do it. Simple. It's simple. Product over reactant. I'm going to give you yours. You solve it. Simple. Very easy. Okay? It's actually very easy. Class, do you understand what I'm saying? Class, do you understand what I just said here? Let me know. Let me know if you understand what I just said here. It's simple. Half-Life, I have it on my channel. Very good. Wow, you guys understand it very well. Now here is yours. Let's say we are having something like now. Okay, I'm trying to work on a reaction, but it's not just falling out now. But this is just on the general basis. So okay, all of this exists in gaseous state as well. I have a full video on this on my channel as well. Okay, so go watch it on chemical equilibrium. Alright guys, with these few points of mine, it's already almost on the 19th April 2024, the day you're writing the JAMB exam will be starting. Okay, so for those who will be writing tomorrow, which is almost time, I wish you all success. Not just you guys, everybody who will be writing the JAMB exam 2024. I wish you all success in your exam. Okay, and I hope to hear your testimonial. You come to my DM or my comment section on my various social media platforms on YouTube, on TikTok, on Facebook to tell me your testimony, and I hope to see you guys in school. Because one is about writing the JAMB, another is about getting admission. Do you understand? So I wish you all success in the exam. You've done so much, you've tried your best, and don't give up. God will surely crown your effort with success. Okay? I wish you all success, and God bless you all. Alright? Never you give up. Always be consistent. You are writing your exam tomorrow, even if you haven't like you are not like the best of best, you can actually do it. Do you understand? You can actually do it. So God bless you all. I wish you all success. And we are done for now. Okay. So I'm gonna put off the live now.